Now going to model the valve port block. As always, start a new standard millimeter.ipt and then start a sketch. I've chosen the XY plane, and the first thing I'm going to do is get the main cylinder, so I'm going to draw a circle in at 41mm, hit E for extrude. Inventor defaults to 10mm, I'm going to do it around the mid plane, hit OK, and you can now see we've got the main part of our valve port block. Whilst we're here, I'm going to change the material to brass, so again, eye properties, physical, into your material there, type in brass, apply and close. I'm now going to start to do, there's two cutaways that are sort of half moon shape, so I'm going to do those first. I'm going to do a sketch on this top face, and we can see we've got an OD of 22mm and an ID of 10mm. So I'm going to draw in these circles, and if we if we do 22 minus 10, we know that the circle diameter is 12, which is divided by 2, so that's 6. So I'm going to start by drawing some construction lines. If you're in the line tool, you can change the format of it up here. So I'm going to change it to construction, and I'm going to draw a line in all the way along. You can see there's a dashed line down there now, so I'm going to draw a couple more lines. I'm going to draw this first one in. And what I can actually do is I can draw, put a dimension between these, exactly the same as sketch geometry. So I'm going to put that one in at 45 degrees. And there's also another line which is perpendicular. And if I start drawing it perpendicular, you can see we get that symbol, which means it's going to be put in as perpendicular as well. So I'm going to draw that in. There's a tool I just want to quickly show you. If you go into, there's an extend tool in Modify, because of course the computer's still looking for 2 dimensions to fully constrain the sketch. But if you go into the trim tool by pressing X, if you hold down the shift button, it actually allows you to use the extend, and you can now see those lines are going right to the outer edge, and our sketch is now fully constrained. So I'm going to draw a couple of circles, but the first thing we need to do is give it a construction line for the PCD, the pitch circle diameter. So I'm still in construction, as you can see, so I'm going to do this at 16mm diameter. And I'm going to draw 2 circles on those intersection points at 6mm. The second circle, actually, I'm just going to draw just to show you another one. If you press equals button, you can actually use the equals constraint to make those two the same. And you can see I've actually forgotten to turn these back into sketch geometry. So if I select both of those and turn that toggle off, they've gone back into sketch geometry, as you can see. And now there's a couple ways to join these up. I'm going to show you both ways. So I'm going to do a centre point circle from the centre. And if I hover over there, you can see the little tangent sign, which means that's now going to be tangential. I forgot to turn construction off again, sorry about that. So I've changed that to a sketch, and I'm just turning that construction off now. The other way you can do it is an arc. So if I start here on the first circle and then on the second circle, if I make that midpoint aligned with the centre line, and then use my tangential constraints, and add it between the arc and the first circle and the second circle and the arc, you can now see that's tangential. And if I add the dimension in there, which we know is 22mm diameter, so an 11mm radius, you can now see we've got that complete shape. And I'm now just going to use the trim tool, trim away all the excess that we don't need. And now I'm going to do an extrude. It's an extrude cut. The reason I trimmed away the inner bits of that circle is now there's only one complete profile, whereas if the circles were left in, there'd have been 3. So I'm now going to change this. It's a cut by 2.5mm. I'm going to do another sketch because there's a hole which is actually on the same PCD, but just to exaggerate it and show you some different techniques, I'm going to use the point up here. I'm going to use my vertical constraint, align it with the centre point of the circle, put a dimension in. We know that PCD is 16. So in here I'm going to actually write 16 divided by 2, and you can see us put it in there. And then you press H for hole tool. Now it's very important when you're doing holes, you don't do a circle and extrude it, you use the hole tool. And the reason for that is when you come to the drawing later on, you can use the hole note and it brings all the details through. So this is a through all hole, so make sure you change the termination to through all. And it's 2mm diameter, hit OK. And you can now see we've got quite a lot of it done. We've got on the underside there's actually 2 more holes, so I'm going to do a sketch on there, and these holes are actually aligned horizontally along the x-axis, as you can see here. So I'm going to do another point, and again I'm going to purposely put it in the wrong place just to show you using your constraints. Horizontally align it with there, and it's 12.5mm from the centre. And in the hole tool, this is a threaded hole, so we need to go to our thread tab just here, It's an isometric thread M5, so just select it in here. Make sure, as always in competition, that you're checking all the details. The designation of this thread is 0.8. There is actually two options, so just ensure you're doing the correct designation, which is highlighted on the drawing as M5 by 0.8. It's a full depth thread, so we've selected that there. Termination isn't through all, it's actually a blind hole which is 5mm deep. So I'm going to hit that one. And there you go, we've got the majority of the features now. What we could do is mirror these about the plane that's down the centre there, down the XZ plane, and then we'd have to do a different mirror for this feature here. But another trick you can use is you can actually use circular pattern, and you can then mirror multiple things at once. So the features I want to pattern is what it's asking me for. So I'm going to select multiples here by clicking first extrusion 2, holding shift and then going down to hold 2. And you can now see we're going to select all of those. You could have selected those one at a time in your workspace, but I always find it easier to do it in the browser. I now need to tell Inventor what the rotation axis is, so we could use, of course, the axis in the z-axis in the origin, or we can use any circumferential face. So I'm going to use this one here. You can see it defaults to 6 instances or occurrences, sorry, through 360. We only need 2. And if you hit OK, you can see it's done all of those features for us. And the final thing we need to do is put the hole down through the middle, which we're going to use the hole tool again, so press H. Now this time, because we haven't got any points, it hasn't picked anything up from the sketch. One of the placement types is concentric, and the first thing it asks you for is which plane are you doing the hole on, so we're going to select this top plane. And you can see wherever you click, that's where it puts the hole. But we now need to give the hole tool a concentric reference, so we're going to use, again, this outer face here. And you can now see what it basically does is it aligns the two center points there, and we can now add it in. So we've got another thread, so Inventor's kept the thread open from last time. So we're in isometric profile, we're in M5, and the designation is M5 by 0.8, and of course it's not 5mm deep anymore, it's actually a through all. So I'm going to change the termination there, hit OK, and there you can see we've finished our valve port block. And the last thing we need to do is save that. So we need to go into our folder, and we've got a project set up in here, so it's the valve port block, so I'm going to save that. I'd actually already done it, so it's just saying there, do you want to replace it, so I'm going to hit yes. And that's another part modelled.